Yeah, good morning children. Today we will learn about the chapter 3 current electricity. So our topic is current electricity. Now what is current? Anything that flows will have a current. For example, if we have water current, heat current, air current, etc. Now when the charges flow, then we call it as electricity. So what is electricity? Basically it is the flow of charge, and electricity, the flow of charge. Again there are three type of charges: electron, proton, and we call it neutron. So proton and neutron, they reside in the nucleus. Only the free electrons, they are easily moving from one place to another place. So we define electricity as it is the flow of electrons, right? So current, the electric current equals to charge divided by time. So current is denoted by I, this is Q by T. So how do we define electric current? It is the flow of electrons per unit time. So we call it as electric current. Now this is the flow only in the conductors. But when we talk about electrolyte, then there is a flow of ions, cations and anions, they flow inside the electrolyte. When we talk about the semiconductors, there is a flow of electrons and hole. So these electron and hole pairs, they move from one place to another place. So here in this topic, in this chapter, we will be talking about the flow of electrons. The electrons are loosely bound, so they can easily move. Now, I equals to Q by T. So 1 ampere, this is the SI unit is ampere. So 1 ampere will be 1 coulomb by 1 second. This is a bigger unit. We will have milliampere, we will have microamperes and others over there. Now how do we define 1 ampere? So if you define like this, 1 coulomb per second, then this is not a correct definition. The definition of 1 ampere current is that when two current carrying wires held parallel to each other, carrying current in the same direction, then separated by 1 meter in air, they experiences a force of 2 into 10 to the power minus 7 Newton per meter. This is the force experienced per unit length. Then we call it as 1 ampere. Now, how many electrons will flow for 1 ampere of current in 1 second? Since Q equals to Ne, so therefore N will be how much? 6.25 into 10 to the power 18 electrons. They flow in 1 second. It's a huge number of electrons. We call it as cloud of electrons. So if I say there is 1 ampere current in a conductor, that means 6.25 into 10 to the power 18 electrons are flowing in 1 second. So this enormous amount of electron, they are known as cloud of electron, they move from one end to the another end, and hence we say that the electrons are drifted from one end to the another end. So here the concept will come, drift velocity. What is the drift velocity? The velocity with which the electrons get drifted from one end to the another end of a conductor when any potential difference is applied. So you will find the drift velocity is about 3.7 meters in 1 hour. The electron can go up to 3.7. This is the cloud of electron I am talking about. But the question will come as soon as we switch on, the bulb glows. Why? The reason is that the electrons which are in the forefront of the cloud of the electrons, they are accelerated and they reach the appliance easily, faster, and later on the cloud of electrons, they drift from one end to the another end. Now, this in this topic, we will learn about the basically electricity is of two types. Electric current is of two types: DC and AC. DC, AC. This is direct current, and AC stands for alternating current. Now, what is direct current? When the current or the potential difference does not vary with time, that means it is unidirectional. When you plot a graph of I versus t or V versus t, then the graph is like this. This is called DC source or DC current. But when we plot the current I versus t and it varies with time, we call it as alternating current or fluctuating current. Either you can plot I or you can plot V. So when the current varies with the time alternately, then we call it as alternating current. In this topic, we will be discussing about the direct current. What are the sources of direct current? The battery, the illuminator, the cell. These are all the DC current sources. Now, this topic, we know that what is electric current? It is the flow of electrons. So when these electrons, the cloud of electrons, they move from one end to the another end, they collide with the other ions present over there, even they collide among themselves. So the obstruction or the hindrance produced by the conductor to the flow of electron is called resistance. Now what is resistance? This resistance, the obstruction or hindrance offered to the flow of electrons in a conductor, I am talking about in a conductor, is called resistance. It is measured in ohm and the symbol is this. So, so resistance is measured in ohm denoted by omega. The resistance, it depends upon R is directly proportional to the length and R is inversely proportional to the area of the conductor. So we say that R equals to rho L by A. What is rho? It is known as the resistivity. And resistivity, it is the inherent property of the material of the body. The resistivity of a conductor is minimum and the resistivity of the semiconductor lies between conductor and insulator. Insulator has got the maximum. So what is resistivity? The resistivity is rho equals to RA by L. So how do we define resistivity? So how do we define resistivity? The resistance of a conductor of unit length having unit cross-sectional area is called the resistivity and it is measured in ohm meter. The reciprocal of resistance is called conductance. The reciprocal of resistivity is called conductivity.